Hey, the extended power rule, the original power rule would only really apply to positive integer exponents, natural number exponents. That actually can be applied to any kind of exponent. So here we're only extending to negative integers, but this could be a fraction, it could be a decimal, it could be anything. In general, this is just always true. If you have x raised to a power, then the derivative of that is whatever number was up here is going to come down and multiply, and then this will decrease by 1. So the derivative of x to the -4 would be -4. The exponent came down to ground level. Now he's going to go down by 1. -4, I'm going to write it out, -1. He drops by 1. So that would be -4x to the -5. And remember, we could, if we wanted to, remember what negative exponents mean. That just means put this guy in the denominator and make it a positive exponent. I could write that derivative like this. Similarly, see, I've already got this guy in the denominator. I could rewrite this if I wanted to as f times x to the -3rd power, because positive in the bottom becomes negative on top with the exponents. So the derivative f prime of x, I'm going to take the power times the constant in front, -12. X, he just comes along for the ride. And now I'll write it out, -3 minus 1. This is going to drop by 1. A lot of mistakes happen with these negatives. So I get -12x to the -4. And then just for fun, let's say we had h of x was 8x to the 1/2. Then his derivative, this rule doesn't explicitly state we can even do this, but I'm telling you, you can. I'm going to have 8 times 1/2. The power is going to come down and multiply the constant. And then my new power is going to be the old one minus 1. So now I got to think, what's 1/2 minus 1? That'd be -1/2. And what's half of 8? That's 4. So I could rewrite this if I wanted, 4 over x to the positive 1/2. And remember, 1/2 just means square root. So that would be 4 over square root of x. This guy was 8 times square root of x. Okay, that's a good place to stop there.